So, last class I was discussing about the plate load test. So, I have discussed that ultimately we will apply pressure and we will measure the settlement, and we will get the pressure versus settlement curve, and that curve will be used to calculate the bearing capacity or the settlement of the foundation. So, I was discussing about the procedure that we have to apply 5 millimeter fine sand before we place the plate, and then we have to apply the rough plate of 30 centimeter to 75 centimeter, either square or circular, and less than 30 centimeter plate is not recommended. And if I use the plate size more than 75 centimeter, then the size effect will not give any significant change in result. Okay. So, now the smaller sizes are used for dense or steep soil, and larger size are used for loose or soft soil, and water you have to remove, and you have to apply a sitting load before we apply the original load. Now, the load are applied the 1/5 of estimated safe load up to failure, or at least 25 millimeter settlement, whichever is earlier. So, first we have to, based on the soil parameters, we have to roughly determine or calculate the safe load by using those bearing capacity equations, that how much load this plate can take, and then we have to apply 1/5 of that initially, then 2/5 of that, then 3/5 of that, and so on. So, that means up 1/5 of increment. So, and you have to go up to failure, or if the settlement is reached 25 millimeter. So, whichever will reach first, you have to stop our test there. So, now after for first 1/5 of increment, we record the time interval for 1, 2.25, 4, 6.25, 9, 16, 25 minutes, and thereafter after 1 hour interval. And once we for the two criteria for clay soil, if I load is increased when the settlement or time settlement curve indicates the settlement exceed 70 to 80% of the probable ultimate settlement, or at the end of 24 hours. That means, for clay soil, if the loading is applied up to 4 hours, then we can apply the next reading or next increment. So, that means maximum we can go for 24 hours, or if we see that the settlement exceeds 70 to 80% of the probable ultimate settlement. Again, as I mentioned, that we have to get those ideas, that what would be the probable ultimate settlement. Then if it reaches 70 to 80% for that particular load, then you stop there, or either you have to keep it for 24 hours. As we know, for the clay soil, it is a long term settlement. So, so this test is short term. So, that is why you have to go for 24 hours. So, there may be a possibility that 24 hours that 70 to 80% settlement may not be achieved. So, that means, but we have to go for 24 hours at least, then we will apply the next increment. But for the other type of soil, if the settlement drops is less than 0.02 millimeter per minute, that means the settlement is less than 0.02 millimeter for a particular minute, you are getting less than 0.02 millimeter settlement, you stop there. Then you apply the next increment of load, and so on. So, that means for the sandy soil, the duration of test will be less compared to the clay soil as expected. Okay. So, the settlement we have to apply minimum 2 dial gauges, and that we have to place the 2 opposite corners of the plate, and the average of these 2 dial gauge reading will give you the settlement of the plate. Okay. So, that means that less load settlement ultimately we will plot from this test. So, now once we get the load settlement plot, suppose we have the load settlement plot. So, this is stress or the load, and this is settlement. Okay. and then we have to use these correlations to get the settlement, actual settlement of the foundation. So, suppose first we are giving the Tarzakian pair correlations. So, this is the correlations, remember that your SAF is the settlement of the foundation and SP is the settlement of the a plate. Actually, the SAF is a settlement of a foundation and SP settlement of a plate. Okay, SP is a settlement of a plate of with BP at the same loading intensity as on the foundation. So, that means SAF is the settlement of foundation of with BP, and remember that BP, BF, BP all are in 70 centimeter, then only you can write 30. So, these 30 you can write if these dimension are in settlement. Okay, dimension of the plates are in settlement. Dimension of the plates are in centimeter. Okay, so now these 30 you can write if the dimension of this the plate and the foundation are in centimeter. So, and this SP is the settlement of the plate of with BP at the same load intensity as on the foundation. Similarly, we can use the second equation also, where dP is the diameter of the plate, dF is the diameter of the footing. This equation also you can use, but here this is the ratio. So, unit is not an important thing. So, that means how we can get that? Suppose we have a settlement of permissible settlement of the foundation is SAF. Okay, and we know the width of the footing and we know the width of the plate. So, we will calculate by using this settlement of the suppose we have the permissible settlement we know. So, that means here we put the permissible settlement of the foundation, then we will get the settlement of the plate. Now, corresponding to that settlement of the plate, the load that we are getting or the stress, that will be the maximum stress that foundation can take. Okay. For example, this is the settlement we are getting. So, we know the settlement of the foundation, permissible settlement of the foundation, we know the width of the foundation or the plate, then you put those values. Only unknown is the settlement of the plate. So, we will get the settlement of the plates. Now, that corresponding that settlement of the plate, the stress that I will get, that will give me the allowable stress. So, that much of stress can be applied on the foundation, because these settlements are in the same load intensity. So, this way I can do determine the load carrying capacity of the foundation also, or vice versa. If for a particular settlement, if for a particular load, if you have the settlement, for example, if you have the loading intensity of the foundation on the other side. So, corresponding to that loading intensity, what is the settlement of the plate you can calculate. Okay. Now, once you get the settlement of the plate, then by using these equation you will get the settlement of the foundation. So, either if you have the permissible settlement of the foundation, then you will get the allowable load carrying capacity of the foundation. If you have the load intensity that is acting on the foundation, then you will get what would be the settlement of that foundation. Then you check whether that settlement is within permissible limit or not. Okay. So, this is these two equations. So, these are applicable for granular type of soil. Now, for clay type of soil, this is the equation that SF by SP is equal to BF by BP. So, these things I have already mentioned, that do not use the plate size less than 30 centimeter, and these are some notes that you should remember, that if it may lead to misleading results if the soil at the site is not homogeneous, because this is important, because this is one of the limitations of this test. Suppose if the soil is homogeneous soil, then it is okay, no problem. Okay, because your influence zone will be one particular soil only, and you will get the bearing capacity or settlement for that particular soil itself. But if your actual soil strata is layered soil and your foundation size is obviously larger than the plate size, Now, your influence, as the plate foundation size is larger than the plate size, then the influence zone of the foundation is also larger than the influence zone of the plate. So, there may be a possibility that the influence zone, as the influence zone of the plate is smaller than the influence zone of the foundation. So, if there is a layer soil, that the influence zone of the plate may not go to a deeper layer, but for foundation the influence zone may reach that deeper layer. So, in the plate load test you will not get the effect of that deeper layer in the test result, whereas your foundation bearing capacity of settlement will be affected due to that layer. So, so that means that layer effect will not be into the data that you are getting by the plate load test. So, that means this is very suitable for the homogeneous soil. If it is a layered soil, then you have to use this data very cautiously okay, when you are designing the real foundation. And obviously, the clay soil, the immediate settlement is not the main settlement. However, platelet test is a immediate test. So, that means a short term test. Again, to use the data for clay soil, again you have to be very cautious. And then for sand bed, if it is a if it is a say not totally saturated, then there is a possibility of the capillary rise of the water, and so your capillary negative pore pressure will develop. So, effective pore pressure will increase. So, that means that may misleading the actual settlement. So, you keep these things in mind, that means you should not use a plate side less than 30 centimeter. If this is a capillary rise or the unsaturated or the soil layer is not saturated, then there is a possibility of capillary rise which may increase your effective stress. So, the data that you will get will not will mislead you. So, that means you have to be careful. And if you want to use the plate load test data for clay soil, you have to be very cautious, because clay soil the settlement is long term, but plate load test is a short term test. Then if the soil is a layered soil, then also you have to be very careful when you using the plate load test data for your real foundation design. So, these are things you should keep in mind. Now, as I mentioned, not only the plate load settlement, bearing capacity also we can get for the cohesionless. This is the equation, and cohesive soil ultimate bearing capacity of the plate is equal to ultimate bearing capacity of the foundation. As you know, the width is not a important thing for the cohesive soil. And this is the cohesionless soil, this is the equation. And one more thing, that your depth of the plate ideally should be the depth of the foundation. If it is not, then you have to apply the corrections during the settlement, because you have to apply the depth correction. In such case, what would be the depth of the foundation? The depth of the foundation will be the difference between the depth of the plate and depth of the foundation. So, that will be, you have to consider as a depth for the correction, for determination of the correction factor. Okay. So, and as I mentioned that when you are calculating the you are testing this plate load test, or you are doing the plate load test by removing the soil. So, and then you are placing it. So, actually the bearing capacity that you are getting from the plate load test, where the second term contribution is not there, it is will be the first term or the second term, or if it is a cohesive soil, only the third term will play into picture, because you are getting that bearing capacity third term contribution in your plate test, because it is a surface footing, because you have removed the soil from your pit. So, surface and as well as C is 0. If it is C is only present and then surface footing, phi third term will be 0 only for the first term. Okay. So, now how to calculate the shape bearing capacity from the plate load test. The shape bearing capacity of a footing can be determined from the load settlement curve. Suppose if the permissible settlement, as these things I have already discussed, I think the same thing is written here, I am discussing again. that if this is your pressure and this is settlement, and you have this kind of curve. So, if your permissible settlement of foundation is with BF is SF, corresponding settlement of the plate can be found from this equation, and then your load intensity corresponding SP is read from the load settlement curve and taken as the safe load capacity of the foundation. As I mentioned that if you have a foundation permissible settlement of the foundation is available, then you calculate the settlement of the plate by using the given equation for corresponding to that permissible settlement. Now, corresponding to that settlement, you calculate the pressure. So, this is the SP, calculate the pressures. So, first you from SF to you get the SP. Now, that SP you use and these you give you the Q safe. And one thing that when you convert something, you convert once only. For example, in this case, suppose you have the settlement of the foundation, then you are converting to this settlement of the foundation to settlement of the plate. Then you are calculating the safe load. Then do not need to convert that settlement for plate to the foundation, because you have already convert once, and these settlements are for equal stress intensity. That means, these settlements that you are in the previous slides I have mentioned that these settlements are for equal loading intensity. So, no need to convert them again. So, that means, the Q shape that you are getting from this plate pressure settlement curve, that is the final, that is the Q shape for the foundation also. That means, that is the common mistake that we found that students are doing, that first you from the foundation you are converting to plate, then you are getting the Q shape, and then you converting that Q shape for the foundation. That means, you will get a very high value. No, that is not true, because this is the settlement for same loading intensity. So, once you convert it for foundation settlement of the foundation to plate, then the corresponding Q shape will be the Q shape for the foundation itself. Okay? So, you convert it for the once, not twice. So, okay, now once you get the shape bearing capacity from the plate, then we have to apply the settlement. For example, that during your test soil is water is not present, but there is a possibility that during rainy season water will present in your site, and then it will make an effect on your bearing capacity. So, that means, if the water is not present, under that condition we have done the plate load test, and then that data you have to correct it. We have to correct. So, that data we have to correct by using these correction factors to incorporate the water table effect. If your test is done under that saturated condition or the actual water table condition, then it is fine, then the correction is not required. But if the test is not done in presence of water, then we have to apply the correction due to water table to incorporate the water table effect. Okay. So, that means, here the difference between the corrections for bearing capacity and the corrections for settlement due to water is slightly different. What is that? In bearing capacity correction, what due to water, our bearing capacity will reduce. Okay. So, that means, we are getting a correction factor which is less than 1, and then we are multiplying that correction factor with the foundation with the bearing capacity. So, that the due to the water, the foundation bearing capacity will be reduced. But in settlement, what will happen? It will be opposite. We will not reduce the settlement because of the water, because water has always the negative effect. So, if it is in terms of bearing capacity, it will reduce the bearing capacity, but in terms of settlement, it will increase the settlement. Okay, because in bearing capacity, we are always going to the lower side, and in settlement, we are going to the upper side, because that is a permissible value, that is a limited value. We cannot go beyond that limit. So, that means, in case of bearing capacity, you will reduce the settlement by applying the correction factor, and in case of settlement you will increase the settlement by using the correction factor. So, that is the case is mentioned here. In actual settlement, this settlement computed from the plate load test divided by the correction factor. So, in bearing capacity you are multiplying the correction factor, but here we have to divide the correction factor, because as the correction factor is less than 1. So, if I divide it by this correction factor, so your settlement after correction will increase. Okay, so, this correction factor we can calculate by two ways. One is the Peck, Hansen and Thorburn method, another is the IS method. So, but there is a difference, that this is the expression here. In this case, depth of dW is the depth of water table below the ground level. So, suppose this is the your equation. In this case, if this is the foundation, so this is your water table position. So, this will be your dW. So, dW depth of water table below the ground level, but here the depth of water table from the base of the foundation. Okay, depth of water table from the base of the foundation. So, this is the difference between two cases. So, that means it means that if dW dash equal to 0, that means the water table is at the depth of the or base of the foundation, then this is 0.5. So, that means if the water table within the surface to base of the foundation, it is always 0.5, but in this case it will change. Okay, so, that means this you can either use this method or the first one, whichever is suitable for you to apply the correction factor. Now, the second method that was talking about, that this is the your method based on SPT. So, if you have, this is the chart, this method is proposed in IS code, this IS 8009 part 1 1976. So, again you have the actual settlement, then you divide it by the correction factor, you will get the actual settlement you will get from the computed settlement by applying the correction factor. And as I mentioned, when you have to apply the water correction, when not. So, once you get the corrected value, and then this W, the correction factor is same as this one, this equation that I have discussed, but here it is given in the graphical form, where D is the depth of the foundation below depth of the water table from the base of the foundation. Okay. So, here your this is the D. Okay, this is the water table and this is ground surface, this is DF and this is the width of the foundation. Okay, so, for example, if D is equal to 0, D is equal to 0 means your correction factor is 1. If your D is equal to B, that means D is equal to B equal to 1, so correction factor if your D by B is equal to 1, D by B is equal to 1 means here. So, your correction factor will be 1, and if your D by B equal to 0, D by B equal to 0 means correction factor will be 0.5. So, if D by B equal to 0, that means the foundation is the base, then correction factor will be 0.5, and if D is equal to B, that means then the correction factor will be 1, and if your water table is in between ground surface, it is in ground surface or in between ground surface and the base of the foundation, then also correction factor is 0.5. Okay. So, that means if it is in between the DF, then also ground correction factor is 0.5. DF is not up to this, DF is up to the base of the foundation. Okay. So, clear that. So, that means it will be if at the base of the foundation and above water table, then the correction factor will be 0.5, and below that within the width of the foundation, you have to calculate by using this chart. And then once you get the n value, this corrected n value you have or you have the, suppose how you calculate the settlement. So, here it is mentioned that first you have to calculate the settlement by SPT. Once you get the settlement, then you have to apply the corrections. So, first let me explain that how I will calculate that settlement, because you have the SPT value and you know the width of the foundation. So, that corresponding n and the width of foundation, you will get the settlement in meter per unit pressure. That means, I will get a settlement say 10 to the power minus 2. That means, my n value is say this is 15, 15, 20, 25, this is 35. So, my value settlement value is this one. So, that means, the settlement value is 10 to the power minus 2 meter, that is for unit per kg per centimeter square. So, that means, for per kg per centimeter square, your settlement is 10 to the power minus 2 meter. That means, the settlement is in meter per unit pressure. That means, this settlement is for unit pressure. If your pressure increases, the settlement will accordingly increase. So, I will explain, I will solve one particular problem, then I will show you how you can use this data. So, right now, if you know the width of the foundation, if you know the n value, you will get the settlement which is in meter per unit pressure, that means kg per centimeter square. And then once you get this settlement, suppose this is your computed settlement. This is your computed settlement. So, this is the computed settlement. Once you get the computed settlement, then apply the this water table correction, then you will get the actual settlement. So, that means, the computed settlement divide the water table correction, you will get the actual settlement. Okay. So, that actual settlement you have to check which is within the permissible limit or not. So, based on that you can decide your width of the foundation. So, next one is the based on the SCPT, that means the static cone penetration test, which is similar, as I mentioned, which is similar to the consolidation settlement. So, that means, for each layer we take SPT value and then we take the CPT value, actually it is SCPT, and then we average that value and then we will apply the equation. For example, suppose we have these 3 layers. So, this is the farm line is the actual cone reading means the QC value. So, actual QC value is this is the QC value. Okay. And then we have to average it. This dotted line is given the average value. So, that QC value for each layer, this is QC1, this is QC2, this is QC3, this is QC4. So, these, because these are the actual of the farm lines, and then we take the average of the for all the layers. So, that means, so that the QC value for a particular layer is same throughout that layer thickness. So, we average that QC value, then you take this, we have to calculate that. Again, the sigma 0 dash delta p is the same way you have to determine as I discussed for the consolidation theory. That means, for this layer also, each layer thickness you have to consider points, and again I will take only the 1 points for each layer. So, this is the center line. So, this is, suppose this is your layer thickness H1, this is H2, H3, H4. So, this will be the H1 divided by 2. Okay. Similarly, this one will be H2 by 2, and this one will be H3 by 2, and this one also H4 by 2. And same way we can calculate the sigma 0 bar effective overburden pressure, then del P the additional stress due to the applied load, and we can use this equation. Then once you calculate it for each layer, then you have to apply the summation, and here h is the thickness for each layer, okay? And then this increase of vertical stress at middle layer, that is middle layer that I have discussed. And then once you get this, we have to each layer, then you have to add them. And then how I will calculate the C value? That C value I will calculate either by using these equation or these equation. So, the upper one is given by the De Beer and Martens 1957, and this one is given by the Mayerhof. So, you can use any of them. So, this is QC is the cone resistance, and again sigma 0 bar is the effective overburden pressure at that point, either A, B, C, D. So, sigma 0 bar you have to calculate that respective points, that means the middle of the each layer, you have to calculate the del P and sigma 0 bar, okay? And then you calculate this equation. So, this is the cone resistance that we will get from SCPT test. So, once you get that, then you will sum them and you will get the settlement. So, which is similar to the consolidation settlement, and I will solve one problem for consolidation settlement also, and then you will see that, or it will be very easier for you to understand in better way that how we can calculate these values and we can determine the settlement. So, I have discussed the consolidation settlement, I have discussed the three methods, that means the three field methods. One is your plate load test, then the SPT and then the SCPT, how we can calculate the settlement of the granular soil. So, next class I will discuss another two methods, that is the semi empirical methods and the influence line methods, and then I will solve one problems or the example problems to show you how we can calculate the settlement, and then we will go for the next part, that is our fourth topic, that will be the beams on elastic foundation. Thank you.